Hey guys, what's going on? Today we're going to be looking at cross sections of prisms and cylinders, and also some surface area. So to get started, the intersection of the plane and a solid or 3D shape is called a cross section. So if you look at the diagram, you essentially view the plane almost like a cutting knife. It's like if you cut the shape right where the plane is and look at the shape, look at the 3D shape, and whatever shape you would see at the top after you make that cut, that's called the cross section. So basically, the cross section is a 2D shape within a 3D figure, depending on where you're cutting it at. So the diagram to the left shows that the intersection of a plane and a triangular pyramid is, so again, you're looking at this shape right here. So it's a triangle. So below that, it says describe the shape formed by the intersections of the plane and the solid. So again, if you take a cube and you get that plane and it looks like you're cutting it right in the center there, you end up with a square. Okay, if you go from a different angle, but still on a cube, okay, and you just cut sort of diagonally, as you see in the picture, it would form a rectangle. Okay, and then on the third one, if you take a more angled approach to cutting, looking at this shape here, might be slightly hard to see, but this would make a trapezoid. Okay, next you take a cone, you go directly horizontal cutting it. You take a look at the top of it right there. That would form a circle. Okay, so classifying 3D shapes or solids. So to name a prism or pyramid, you use the shape, of the bases. So there's always two bases, okay, on a solid or 3D shape. So there's a bunch of lateral faces, okay, but there's only two bases and they're parallel to one another, which basically just means one's on top, one's on the bottom, or if it's on its side, one's on the left, one's on the right. So the two bases of a prism are congruent polygons in parallel planes. So, for example, you see a pentagon here, okay, and then clearly the other one is parallel, or meaning at the bottom. Okay, so this would be a pentagonal prism. So some things we're going to be looking at, surface area. Is the sum of the area of all the faces, okay? So every single shape you see on the 3D shape, you basically find the area of all of those shapes individually, add it all up, and that's the surface area uh, of the shape. Why we look at things like surface area? A real easy example would be taking a more real life approach. Even if you were just trying to paint something, right? You wouldn't paint the inside per se. You're not filling up the 3D shape with paint, but you just want to paint the outside. You want to know, well, how much paint would I really need? You can find the surface area of whatever it is you're trying to paint. So the lateral area is basically part of the surface area. So it's the sum of the area of all the lateral faces. Okay, so basically every shape that's not a base. Okay, so you have two bases. Every other shape you see that makes up the 3D shape, every other face is a lateral face. Okay, So you'll always have two bases, and then everything else is just called a lateral face. So the lateral area is just talking about specifically just the area of those lateral parts. We usually break this up to specifically call it lateral area because your bases are typically a different shape, okay, but they're the same shape for your bases, and then your lateral faces are a different shape from your base, but they are all typically the same shape. So basically, it's kind of easy to find your surface area, and then by breaking it up from your bases and your lateral faces. Okay, so note height is the distance between the bases. So lateral area and surface area of prisms. So lateral area will be congruent to P times H, where P is the perimeter of one base, and then you're going to multiply it by the height of your prism. So surface area you could write as fundamentally it'll always be this. Okay, fundamentally this is your general equation for all prisms. So lateral area plus the area of both of your bases, 2b. Okay, so considering we just said the lateral area is perimeter times height, you could say that the surface area for a prism is P times H plus 2b. So lateral area and surface area for a cylinder. So the lateral area is 2 pi r times h, which note 2 pi r is your circumference of a circle. Okay, and we've said in the past, circumference is essentially the perimeter of a circle. So again, fundamentally, this is still the exact same equation. It's just the fact that now we have circles. So we have pi involved, and we use circumference 2 pi r instead of just saying the perimeter of one base. So the surface area for a cylinder is 2 pi r times h plus 2 pi r squared. So again, pi r squared is the area for that base, that circle. And then again, of course, there's two of them, so you multiply it by 2. So again, fundamentally, it is still this equation. This will always be your fundamental equation for surface area for all of these 3D shapes. It's just depending on what shape it is, you can just make it a little more specific. So let's look at examples 1 and 2. So it wants the name, and it wants you to, in this picture, in this little box here, draw your base and get the perimeter, and then the area of that base. So the base are these two guys here, these two rectangles, and again, there should only be two of them. So basically we have a rectangle, so the name should be a rectangular prism. And we have, it tells us this side is 7 inches. And then, if you note, this side here, same as this side here, and that's 14 inches. So the perimeter is just 14 plus 14 plus 7 plus 7. So basically, it goes to 28 plus 14, which is 42. The area for one base, again, you just do length times width, so 14 times 7, okay, which goes to 98. And this is inches, and this is inches squared. Okay, so now it wants the lateral area. So again, the lateral area is going to be perimeter times the height. So our perimeter we just said is 42. And and then times your height, which in this case is 11, so that goes to 462 inches squared. Okay, so the surface area in total is going to be your lateral area plus the area of both of your bases. So you got 462 plus 2 times 98. Okay, so you do 462 plus 2 times 98, and you end up with 658 inches squared. Okay, so let's look at the next one. So we have this is a cylinder. So we have a circle, the radius of 6. Okay, so again, the perimeter of one base. Okay, it's just pi r squared. So in this case, 36 pi inches squared. Or, oops, sorry, that's the area is pi r squared, so 36 pi inches squared. The perimeter, again, is just the circumference, so 2 pi r, so 12 pi inches. So the total lateral area, okay, again, is the perimeter of one base times the height. So we have the perimeter of one base we just said is 12 pi. And then times the height, so times 12. So this goes to 144 pi. Okay, so the surface area would be the lateral area, 144 pi, plus the area of both of our bases. So we have two of them, and the area of one of them is 36 pi. So that's 144 pi, plus, then we have 2 times 36, which goes to 72 pi, and then adding 72 and 144, we get a total of 216 pi. For your units, you could put, sorry, I've been putting inches, it's meters. So meters squared, meters squared, meters squared. And of course, if you want to round, you just plug pi into your calculator. But okay, guys, that is it. Thank you.